So welcome all for today blocks revision. So today I want us to look on decision making. I want us to look at two topics, decision making and then the cost forecasting or the forecasting and correlation. So let's start with the decision making. They want us to go directly to our past papers. So we're looking at decision making. Just a quick recap on what entails decision making. So I want you to go through the steps in decision making, and we see that in decision making, one, you need to identify the objective. Once you identify the objective, you identify all the available options. Once you identify the available options, then you determine all the possible outcomes. To get the option and the outcomes, then you can gather data for both the options and the outcomes. And then from there, you develop what you call a payoff table. Payoff table. Remember, I said that payoff means the profit. So that's a thing you need to note, that payoff means the profit. Then you also said that we have two types of decision. For the types of decisions, number one, we said we have what we call the single stage decision. And then number two, we have the multiple or multi-stage decision. Those were the two types of decision. Then for the single stage decision, we see that it's evaluated using the payoff table. But for the multiple stage decision, it's evaluated using decision tree. That's the difference between the two. For the single stage and the multiple decision. And then we see that for the single stage, this is where one outcome becomes final and conclusive. But for the multiple stage, this is where an outcome gives rise to another outcome. Then we also looked at the environment of decision making. And we see that we have four major environments. One was the environment of certainty. Then we say that we have environment of uncertainty. Then we had environment of risk. And also we had environment of competition. So those were the environment in decision making. And then in each, I gave you the various methods you can use to evaluate decision. For example, environment of uncertainty. For uncertainty, this one you don't require to make any decision because in this case, the outcome is well known in advance. For uncertainty, we said we have a method you can use such as max-maxi, max-min, mini-mini, Laplace, Howicks. And environment of risk, we say that we use EMV and EOL. And then we say that an environment of competition, that's where we apply the game theory. We apply the game theory. Good. So now with that, let's do a question from the past paper. So open with me November 2019, question 5A. November 2019, question 5A. November 2019, question 5A. So you're told that a businessman has three alternatives open to him, each of which can be followed by any of the 5 payoff conditional possible events in millions of shillings as given below. So we have alternative A, B, C, and then you have the outcome. You have event 1 to event 5. Required, advise the businessman on the best alternative under, so you are given all those criterion. So now using those criterion, so we start with the first one, which is the max min. So in this case, already you are given the payoff table, so you don't have to develop the payoff table because you're already given the payoff table. So you are to advise the business on the best alternative. So number one, we are to use the max min. Yeah, max min rule. And the max min, you take the maximum of the minimum. So start with the minimum. And in this case, we have three alternatives. It's either A, B, or C. So it's the maximum of the minimum. So you take the minimum. So for alternative A, the minimum payoff we have is negative 12. For B, the minimum we have is negative 6. And then for C, the minimum we have it's 0. We have already have the minimums. And then it's the maximum of the minimums. Once we have the minimum, you select the maximum, and the maximum here we have it's 0. So that means in this case, you should adopt alternative C. Let's go to number 2. Number 2, you have to use the maxi rule or maxi criterion. So between A, B, and C, so this means is the maximum of the maximum. So you take the maximum. For alternative A, the maximum we have is 6. For B, the maximum we have is 16. And then for C, the maximum we have is 12. And then in this case, we are taking the maximum of the maximum. So already have the maximum, then you select the maximum. In this case, the maximum will be 16. So in this case, you should go with option B. Remember, we said that maxi and mini, they are applied when the decision maker is optimistic. Then for the max min or the minimax, they are applied when the decision maker is pessimistic. Good. Let's go to number 3. Number 3, you are to use the Harwicks criterion, assuming the degree of optimism is 0.6. So number 3, we use the Harwicks. And we say that under Harwicks, you take alpha times the best payoff. You add 1 minus alpha, you multiply by the worst payoff. That's the formula. So A, B, C, where alpha in this case is the coefficient of optimism, and you're given the coefficient of optimism is 0.6. Then you multiply by the best payoff. For the alternative A, go for alternative A, which was the best payoff. The best payoff was 6. For B, the best payoff is 16. And for C, the best payoff is 12. And then you add 1 minus alpha. If alpha is 0.6, that means 1 minus alpha is 0.4. And then you multiply by the worst payoff. The worst payoff, that's the minimum. So let's start with the alternative A. Alternative A, the minimum we have is negative 12. B, the minimum or the worst payoff is negative 6. And for C, we have it's 0. So with that, let's compute. We have it's negative 1.2. Here we have 7.2. We have 7.2. So in this case, once you have the, we have the 2, you take the maximum, and the maximum it's either B or C. So you can select any, either B or C. And then lastly, number 4, Laplace criterion. Number 4, we are to use the Laplace. And we say that the Laplace is the same as the average. So between A, B, and C, you get the average of the payoffs. So for alternative A, we had 6. You add 2, you add negative 2, you add negative 12, you add 4, then you divide by 5. And then for B, it's minus 6, minus 3, plus 10. You divide by 5. And then for C, we have 12. You add 8, 4, 0, 6. And then you divide by 5. You get the average. So that's negative 6. That's 2. You have negative 0.4. Then we have 117. 17 divided by 5. You have 3.4. 24. That is 32. You have 6.4. And then you select the highest for the appraisal. Remember you are getting the average of the profit. So therefore you take the one with the highest average profit. In that case, they adopt strategy C. Strategy C. Good. So you have that. You can take a screenshot of that. We do another question. Let's try another one. May 2017, question 2C. May 2017, question 2C. So hoping we are there. So we are told that. Yeah, that's May 2017, question 2C. ABC Limited has recently developed a new product named X. The demand for X is expected to be low, medium, or high, with probability of 0.25, 0.45, and 0.3 respectively. Those are the outcomes. Remember, we see that how can you differentiate between the option and the outcome? We see that for the outcome, mostly they do have probabilities. The product is to be manufactured at small or large scale production with the following annual profit estimates. So we have small scale production, then we have large scale production, then we have the demand required. Advise ABC Limited on the best course of action based on the following approaches. Number one is the expected profit. So number one is the expected profit. Expected profit is the same as EMV. So in this case, we already given the payoffs. And in this payoff, we have two alternatives. So it's either the small scale production or the large scale production. So it's either small or large scale production. So we get the EMV. EMV is all about taking the payoffs, then you multiply by the probabilities. So for example, if you adopt the small scale production, you have the expected profit. You can get 40 with probability of 0.25. Then you also add, you can also get 140 with probability of 0.45. You can also get 180 with probability of 0.3. Then for the large scale, you can get 5 times 0.25. You can also get 90, probability of 0.45. Or you can also get 280 with probability of 0.3. So let's get the EMV on that. So you are getting 127. We have 125.75. Then based on the EMV, we see that you take the one with the highest expected monetary value, and in this case is 127. So in this case, you should undertake small scale production. Number two, your device ABC limited on the best course of action based on the following approaches. So number two, it's all about minimizing risk. Minimizing risk. So when minimizing risk, remember when I was introducing the decision making, we say that in this case, we have various decision makers. We say that decision making process is guided by what we call the risk preference. And we say that we have the risk takers, we have the risk averse, and we have the risk neutral. Then we say that risk is a chance of something unfavorable might happen in the future. And I gave you two alternatives of measuring the risk. We say that to measure the risk, you can either use the standard deviation or CV, that's the coefficient of variation. So let's compute the standard deviation. That's what we're supposed to evaluate using. In this case, we want to minimize the risk. So let's get the standard deviation, and we say that to get the standard deviation, you take returns minus expected return square probability, you add all of them, and then you get the square root. So we have for the small scale, and we have for the large scale. And we have the returns. So return in this case is our profit. If you adopt the small scale, when the demand is low, you can get 40. When medium, you get 140. When it's high, you can get 180. Then you deduct the expected return. Now, expected return in this case is the expected monetary value. How much was the EMV for the small scale? It was 127. You get the deviation. Once you get the deviation, then you square, then you multiply by the probability of that happening. So it's 0.25, 0.45, and 0.3. We do the same for the large scale. For the large scale, we have the returns. We had 5, 90, or 280. You deduct the EMV, and EMV, when you adopt the large scale, it was 125.75. You get the difference. Then once you get that, you get the total now. You'll be having 28, 11. Then once you get that the summation, that's when you get the square root. So that means the standard deviation will be 53. Now I do for the large scale. So you have 36.45. Then once you get the total, then you get the square root. You get 106.57. So remember, the standard deviation is a measure of risk, and the higher the value, the higher the risk. So now, based on the standard deviation, for small scale, we have 53, and then for large, we have 106. You take the one with the lowest risk. So and in that case, they should also adopt the small scale. Or let's also evaluate using the coefficient of variation. Now, mostly for the coefficient of variation is adopted whenever there is a conflict between EMV and the standard deviation, and CV, you take the standard deviation over the EMV times 100%. And for coefficient of variation shows the percentage or the risk you take for you to generate 1 unit of returns. So for example, for small scale, so let's do for small and for large. The standard deviation we have for small scale was 53. And for large we had was 106.57. Then you divide by the EMV, and the EMV for small scale was 127. You multiply by 100. And then the other we had was 125. 125.75 times 100. So here we are getting it's 84.75%. Yeah, I'm getting it's 41.73%. So for CV and standard deviation, the lower the value, the better. So in this case, for small scale, we have 41. So they should adopt small scale. You see what it means for CV, that for us to generate 1 unit of profit, we are taking a risk of 41.73%. Then for the large scale, for us to generate a profit of 1 unit, you are taking a risk of 84.75. So that means for large scale, it's more risky as compared to the small scale. So in this case, if you want to minimize the on risk, you should adopt the small scale. Good. So you can take a screenshot of that. So hoping you have now, they already have the screenshot. So let's do another question. And do another question. So open with me November 2015. November 2015. Question 4D. November 2015, question 4D. November 2015, question 4D. So part 4D, you are told that Jane Cherop was employed by Golden House Limited as a sales agent last year. And during the year, she was able to sell up to a maximum of 600 houses in a month. So the maximum number of houses to be sold was 6 houses. Due to good performance in the past year, the company has offered Jane Cherop one of the following 3 salary plan for the next year. So we're given plan A, a 25% salary increment to 50,000 per month. And then plan B, a fixed monthly salary of 20,000 per month plus a commission of 12,000 per house sold. Then plus C, no monthly salary, but a commission of 20% per house sold. Required. The optimal salary plan for Jane Cherop based on the, so you are given that. Number one, use the max min criterion. Then number two, the optimal salary plan for Jane Cherop based on the minimax regret criterion. And then number three, assuming that during the year, the distribution of the houses sold by Jane Cherop for the 12 months was as follows. So you have the number of household and the number of months. Advise Jane Cherop on the optimal salary plan based on the expected value criterion. You get your 9 marks. So these are single state decision. So first of all, you have to develop our payoff table. And we say that the payoff is the profit you are getting. And in this case, we say that when developing a payoff table, you have your options and you have your outcomes. And in this case, we have 3 options. We have plan A, plan B, plan C. Then we have the outcome. Now, in this case, the outcome will be based on the number of the houses sold. And you're told that the maximum number of houses to be sold is 6. She can sold is 600. Is 6 houses. So that means for the outcome, you can sell 0 houses. 1, 2, 3, 4, 5, and a maximum of 6. That's what we need now to evaluate. So now let's go to plan A. Plan A. Plan A, you are told that a 25% salary increment to 50,000 per month. So that means she was receiving a given salary, but in this case to be increased by 25%. That means per month you'll be receiving how much? 50,000. So under plan A, if you sell 0 houses, still get your salary of 50,000. If you sell 1 houses, no commission, you still get 50,000. If you sell 2 houses, your salary does not change. 50, 50, 50, 50. Now let's go to plan B. Plan B, you get a fixed monthly salary of 20,000 per month plus a commission of 12,000 per household. So plan B, you get a guaranteed salary of 20,000, and then any house you sold will be receiving a commission of 12. So what does that mean? That means if you sell 0 houses, your fixed salary is how much? It's 20,000. If you sell 1 houses, you'll get your 20,000 plus a commission of 12,000 per house. And in this case, if you sell 1 house, that means you are getting a commission of 12. So 20 plus 12, you get that 2. Then if you sell 2 houses, that means you have a salary of 20,000 plus a commission of 12,000 per house. So 12,000 times 2 get 20, 24 plus your fixed salary of 20,000. That means you'll be having 44. If you sell 3 houses, it's 3 times 12. That means you have a commission of 36 plus your salary of 20,000. And that means you get how much? 56. Then if you sell 4 houses, that means you have it's 4 times 12, and then you add 20. So you'll have 68. This one you will have, is it 80? 80. And the other one will have 92,000. Good. Let's go to plan C. Plan C was that no monthly salary, but a commission of 20,000 per house. So there is no monthly salary, but you get a commission of 20,000 per household. So that means if the outcome you sell, if you sell 0 houses, that means you'll get nothing that month. If you sell 1 house, no salary, but you're getting a commission, and the commission per house is how much? 20,000. So you'll get 20,000. That means if you sell 2 houses, you'll have 40,000. If you get 3 houses, 60. If you sell 4 houses, 80. If you sell 5 houses, 100. If you sell 6 houses, you get 120. Those are the payoffs. So with that now we can be able to answer required number 1. The optimal salary plan for Jane Cherop based on the max min criterion. Max min criterion. And the max min criterion is the maximum of the minimum. So you start with the minimum. So you have plan A, plan B, plan C. Now using the payoff table, for plan A, the minimum we have is, so that one means be 50. Plan B, the minimum we have is 20,000. And plan C, the minimum we have is 0. So we have the minimums. So from the minimums, then you select the maximum. And the maximum we have is 50,000. Yeah. We say that this one you adopt when you are pessimistic. You are not sure. If you are not sure, that's what it means. You just take the guaranteed salary. Eh? So in this case, adopt plan A. Let's go to number 2. Number 2, the optimal salary plan for Jane Cherop based on the minimax regret. Minimax regret. It's also known as the salvage regret. Now, if I may take you back, remember we said that when you are making a decision under minimax regret, in this case, you are regretting. And I say that when you are regretting, you cannot regret the payoffs or the profit. You regret the losses. So for you to adopt the minimax regret, you have to develop what you call the loss table. You develop the losses table. Option, plan A, plan B, plan C, 0, 1, 2, 3, 4, 5, 6. So how do we develop? Remember, in this case, we have the payoff table. How do we transpose the payoff table for you to develop the loss table? We say that when coming up with a loss table, you use the outcome, not the option. So for example, in this case, let's go to the outcome. If you sell 0 houses, those are the outcomes. You take the maximum. The maximum you have is 50. So you take 50 minus 50, you get a 0. 50 minus 20, you get 30. 50 minus 0, you get 50. Yes, that's how I showed you on how to develop the loss table. If you sell 1 houses, remember in this case, I'm using the outcome to develop the loss table. I'm using the outcome. If you sell 1 houses, so from that column, you take the maximum, and the maximum is 50. So you take the maximum, you deduct all the other. 50 minus 50, you get 0. 50 minus that 2, you get 18. 50 minus 20, you get 30. If you sell 2 houses, the maximum you have is 50. 50 minus 50, you get 0. 50 minus 44, you get 6,000. 50 minus 40, you get 10,000. If you sell 3 houses, the maximum you have from that column, we have is 60. 60 minus 50, you get 10,000. 60 minus 56, you get 4,000. And then 60 minus 60, you get 0. If you sell 4 houses, the maximum you have is 80. 80 minus 50, you get 30. 80 minus 68, you get 12. 80 minus 8, you get 0. If you sell 5 houses, the maximum you have is 100. 100 minus 50, you'll get 50. You'll get 20. And you get 0. If you sell 6 houses, the maximum you have is 120. 120 minus 50, you get 70,000. 120 minus 92, you get 28. And then you get 0. It's the same how we used to get the value of information. That means, for example, let's evaluate this for the 6th one. If you sell the 6 units and you had the information, the maximum you could have selected, usually select the maximum. The maximum you could select from that column is 120. So you just take that maximum, you deduct the other so that you can determine the opportunity loss. So once we have that, now we can adopt our method. It's called minimax regret. Minimax regret. Now we can regret because we have the losses. Plan A, plan B, plan C. Minimum of the maximum. So we take the maximum, but in this case, we're using the loss table. So for plan A, the maximum you have is what? It's 70. That's the maximum loss you can suffer. For B, the maximum loss you can have is, that's 28. No, we have 30,000. C, the maximum loss you can suffer is how much? 50,000. Now, those are the maximum loss you can suffer. And then from there, you choose the one with the minimum loss. And the minimum loss here we have is 30. So if you are risk-averse person, in this case, you should adopt plan B will suit you. And then number three of the question. Number three, we are told that, assume that during the past year, the distribution of the houses sold by Jane Cherop for the 12 months was as follows. So now you're given the distribution for the entire year, the number of houses sold, and the number of months. Advise Jane Cherop on the optimal salary plan based on the expected value approach. Now, expected value approach is the EMV. So in that case, let's develop the payoff table. Based on those outcomes. That was for the entire year. So we have plan A, our option. We have plan A, plan B, plan C. Now, based on the number of houses sold. So in this case, we look based on the months. So we have the number of months. So we have 0, 1, 2, 3, 4, 5, 6. So in that, how do you develop that? So now let's be here. Let's be here. We want to come up with a payoff. Now, assuming that for plan A, let's go back to plan A. Plan A, in this case, you're getting a fixed salary of 50,000. That means nothing will change. So that means regardless of the number of houses sold, you get to a 50,000. What about plan B? Let's go to plan B. Now, plan B, you are getting a fixed salary of 20,000 per month plus a commission of 12,000 per houses. Let's be there. So just give me a minute. Let me be looking at that. We can continue. So now we are evaluating the option alternative 3. using the EMV. Let's do that question again. Do that. Assuming during the past year, the distribution of houses sold by Jane Cherop for the 12 months was as follows. So we have the number of houses, and then we have the number of months. Advise Jane Cherop on the optimal salary plan. So you're saying that if you adopt plan A, remember for plan A, nothing is changing. Your salary will still be intact at 50,000 per month. So that means in that case, we are adopting the, actually this one we are not supposed even to, these are the number of houses. Let's use the easier way. The easier way, we do this. Now you're getting, what do you expect? So we have plan A, plan B, plan C. And plan A, regardless of the number of units you sold, per month you are getting your salary of 50,000. And in this case, you're given for the past year. So that means you multiply by 12. So it's 50,000, you multiply by 12. That means per year you'll be having 600,000. Let's go to plan B. Now, plan B is a fixed monthly salary of 20,000 per month plus a commission of 12,000 per houses sold. So that means you'll be having a fixed salary of 20,000. You multiply by 12, that's the minimum guaranteed salary, plus the commission. And the commission per unit per household is how much? Is 12 times. I want to give you a task. Can you go to note number 3? Can you add the number of months? Add the number of months should be equal to 12 because it's an entire year. That is 12. Then we have the number of houses sold. So if you want to get the total number of units sold, for example, number of houses sold, for example, 0, he sold nothing houses for how many months? 1 month. Then he sold 1 houses for how many months? 2 months. He sold 2 houses for 1 month, 3 houses for 2 months, 4 houses for 4 months, 5 for 3 months, 6 for 2 months. So that means during the year, how much is the expected number of units sold? Just multiply that. It's 0 times 1. Then you add 1 houses for 2 months, 2 times 1, 3 for 2 months, 4 for 1 month, 5 for 3 months, and then 6 for 2 months. So that means during the year, he sold how many units? That's 12 plus 15, 12 plus 15. Then you add 4, 4 plus 6, you get 10. Then 2 plus 4, that's 4, and you get 41. So that means during the year, he sold 41 houses. So it will be, let's go back to plan B. 20,000, that's a minimum guaranteed salary for 12 months, times 12,000 per household. And during the year, the number of houses sold in Ngapi? 41. So that means during the year, how much is that? So plus 20,000 times 12. You'll get 732. Let's go to plan C. Plan C. In plan C, you are told that no monthly salary, but a commission of 20,000 per house. So that means if there is no minimum salary, you are getting a commission of 20,000 per house. You take 20,000, and how many houses did you sold during the year? That number of houses sold was 41. So during the entire year, you got 820. So based on the expected monetary value, the maximum you have is what? It's 820. Go with the one with the highest. So using the EMV, you want to take plan C. Good. So you can take a screenshot of that. Then we move to the next question. Good. So let's try another question. Open with me, May 2016. May 2016. Question 4A. May 2016. Question 4A. Viwanda Limited is in the production of product named Nguvu. The production cost of the product is shillings 500 per unit, excluding the packaging cost. The product is sold at 1,000 per unit. The company is considering the purchase of to purchase one out of the 3 different packaging systems. The cost data for the 3 packaging systems are as follows. So we're given the packaging system, and you're told that we only need to buy one of the 3 different packaging systems. So we already know our options. Our options, it's either system A, B, or C. Then we're given the purchase cost. Then we have the variable cost per unit of product. Then we have the scrap value. All the 3 packaging systems have a useful life of 1 year, after which they will be sold at an estimated scrap value, at the estimated scrap value. Yeah, scrap value is what you get upon the year end of the economic life. The probability distribution for the demand for product Nguvu is provided as below. You're given the demand in units and the probability. So that means those are the outcomes. Recommend the packaging system that should be purchased by Viwanda Limited. So in this case, they have not specified which method to use. But since you are given the probability, use EMV. You see that whenever you're given the probability, that's what you call environment of risk. And for environment of risk, it's either use the EMV or the EOL. So you develop the payoff table. And we say that, what do we mean by payoff? Payoff is the profit. What are options? What are outcomes? For the options, we have 3 options. It's either system A, B, C, and then we have the probability. Remember, I had already given you the format for payoff table. Then for the outcomes, it's all about the demand. You can sell 100 units, 200 units, or 400 units. And the probability of selling 100 is 0.3, 0.6, and 0.1. So how do you develop the payoff table? In this case, you're not given the payoff. And you see that the payoff means the profit. So that means in this case, we have to develop the profit. Now, based on the information given, how can we determine the profit? Can you read the question again for 1 minute? You look at the what do we have and how can we use that information for us to determine the payoff? So you can look at that, read it for the next 30 seconds or 1 minute. Now let's be here. You already have gone through that. So what you'll do, you have the demand in units. So if you have the demand in units, so that means, for example, in this case, for machine A, you may sell 100 units, 200 units, or 400 units. So you'll take the revenue minus the cost. So that means if you take machine A and you produce 100 units, so the revenue will be 100 units. How much was the selling price? The selling price per unit was how much? 1,000. You get the revenue. Plus there is another profit. There is scrap value. Now, scrap value is what you get at the end. So that one is an inflow. And how much will you get? For machine A or system A, you'll get 10,000. Then you minus the cost. You are given the variable or the production cost. The production cost per unit is 500. So if the demand is 100, that means you'll take 100 units. You multiply by the production cost of 500 plus there is another cost, the purchase cost. And the purchase cost for that machine will cost an amount of 100,000. So that is more of like the fixed cost. Let's go to the second one. So this one, if the production is 200,000, you'll take 200,000 times 1,000 plus machine A, the scrap value does not change, it 10,000 minus the production cost will be now 200 each at 500 plus the machine cost at 100. All for 3, you do this. I mean, for the other one, it's 400. You multiply by 1,000 plus the scrapped value. And how much do we expect to get? A scrapped value of 10,000 minus the production cost, 400 units. You multiply by 500, then you add another cost of 100. And that's what you're supposed now to do for A, B, and C. So once you get the payoff table, then from there you can determine your E and B. I don't want to go deep into that. I just wanted to show you on how to develop. Or alternatively, you may argue like this way. You may argue like, for example, for A, we had 3 alternatives. We have, it's either 100, 200, or 300, of which this is the best option. So in this case, you may have 2 workings you might do. So if you produce 100, that means you take the revenue minus cost, or you take the selling price minus the variable cost. So in this case, the selling price is how much? The selling price is 1,000. You take 1,000. You minus the production cost. How much was the production cost? And the production cost was 500. That's what you get. So selling price minus the variable cost, you get contribution margin per unit. Then, because the variable cost and the selling price are not changing, you multiply by the number of units. So here you are producing how many units? 100. Here you're producing 200. Here you're producing, sorry, it was 400. You're producing 400. So once you get that, you get the total contribution margin. Are we together? And once you get the total contribution margin, you add the total. So what you get here is what you bring here now. For each. Now, once you determine for all of them, now that's your payoff. You are taking the selling price minus the variable cost, and then you multiply by the number of units to get the total contribution margin. You treat it as your payoff. Once you get your payoff, in this case, you have to make a decision between A, B, and C. So how do we get the E and V? Now, E and V in this case, you'll be taking what you got here. For example, Now, let me just guess a figure. Assuming this will be 60, this will be 80, and this one will be 100. So for A, for example, for machine A, you'll take 60, you multiply by the probability, which is 0.3, plus, you can also get 80, that's the total contribution margin with a probability of 0.6, or you can also get 100 times 0.1, you get the total contribution margin. Once you get the total contribution margin, then you add. How much is the scrap value for machine A? The scrap value was 10,000 minus how much was the purchase cost for machine A? The purchase cost for machine A was 100,000. You get EMV. You go to B. For B, you do the same. You take the total contribution margin times the probability. You get the total. Then you add the scrapped value, and the scrap value for machine B will be how much? 20,000 minus the purchase cost of that machine will be 200,000. You get your EMV. For C, you do the same. You take the total contribution margin times their probabilities, then you get the total. Once you get the total, you also add the scrapped value. Scrap value for machine C will be 40,000 minus, you minus the purchase cost of 400,000. As simple as that. But there's something we have left out. Remember, there was also the variable production cost of 1,500. I didn't see that. I only saw the production cost. So that means in this case, for the production cost, you'll take 500. Sorry for that. Also, there was a variable cost. Can you see the variable cost per unit? You also factor in that. Might do that question again. I didn't see that, the variable cost per unit. But it's okay, provided you have the concept on how to develop the payoff table. So we might take a screenshot of that. Before we do, I want us to do one question on multiple decisions. Multiple decision. So take out your handout. Take out your handout. You go to handout page 8. Handout page 8, question 2. Handout page 8, question 2. There is that question there. So if I take you back on where for the multiple decision, we say that there are various tools used, and tools used, we had that, we also had that, we had that, and we had that. So we say that this means the start of an option. This means the end. This represents the outcome, and this presented the option. Then I gave you an NB that you always need to start with a sketch. Once you start with a sketch, then you draw from behind. Draw from behind. And then we say that in case there is more than one decisions, not options, more than one decision. For example, assuming you have 2 decisions, you start with the second one or the last one. So that's what we said. In case we have 2 decisions, always start with the second decision. Good. So now let's do that question. We do that question. And we are told that Colin Simiu recently acquired a piece of land in Kamuru. A property development company has offered him 300,000 for the piece of land. So that means if he decides to sell the land, he'll get 300,000. He has to make a decision on whether to cultivate the land or sell to property development company. Can you underline that? That's the first decision. He has to make a decision on whether to cultivate the land or sell the land. So that's the first decision with two options. It's either you cultivate or you sell. Good. If you decide to cultivate the land, there is probability of getting high, medium, or low harvest. Those are the outcomes. You cannot control the harvest. Then the expected net income for each of the above states of harvest are shown below. So we're given the state of harvest. If it will be high, you will get a net income of 500. So those are the payoffs. If it will be medium, you get 100,000. If it's low, you get a loss of 20,000. From the past experience, there is a 10% probability that the harvest will be low, 30% probability that the harvest will be medium, and 60% that the harvest will be high. Then you are told that Colin Simiu can engage an agricultural expert. So let's repeat that again. Colin Simiu can engage. Can you underline can? Underline can. So that means it's not a must. Yeah? Colin Simiu, you remember you're not told that Colin Simiu will engage. You're told that Colin Simiu can engage an agricultural expert. So that's another decision. You can either engage an expert or no expert. That's the second decision with two options. You engage an expert or no expert. So Colin Simiu can engage an agricultural expert to carry out the survey of the productivity of the land, which will cost him 30,000. The expert gives the following information as the reliability of such survey, which can either be accurate or not accurate with equal probability. So if you engage an expert, we have two outcomes. The information from the expert can either be accurate or not accurate with equal probability. So it's 50-50. Then you are given the state of the harvest, result of the survey, when it's accurate, when it's not accurate. Required, construct a decision tree for the above problem. So how do we construct that? So in this case, how many decisions do we have? We have two decisions. The first decision is whether to sell or cultivate. The second decision is whether to hire an expert or no expert. So in case we have more than one decision, we say that you start with the last one. And the last decision we have is what? It's expert or no expert. So let's start with a sketch. You draw like that. You start with the second one or the last one. Here you can engage an expert or no expert. If you engage an expert, expert will give you two outcomes. His information can either be accurate or not accurate. Now, once you are through with the first option or first decision, now you can go back to the first decision. So whether it's accurate or not accurate, you need to make another decision. So I will say that whenever you're having a start of a decision, use a box or a square one. So when it's accurate or not accurate, there is another option. Which was the other decision? You can either sell or cultivate, sell, cultivate. If you engage no expert, still you can either sell or cultivate. Yeah, for the option, use a dotted line. So if you saw this is selling or cultivate, sell, cultivate, sell, cultivate. If you sell, how many outcomes do we have? If you sell, outcome ni moja tu. You have been offered, you are selling to this property development company, of which they will pay you 300. If you sell, outcome is 1. But if you cultivate, there are 3 outcomes. That's the state of demand. At the state of harvest, the harvest can either be high, medium, or low. If you sell to the company, if you cultivate, high, medium, low. If you sell to the company, if you cultivate, high, medium, low. So that's how your decision tree will look like. So that's the sketch. So once we have the sketch, now we can draw a fair copy. How do we draw a fair copy? We say that when drawing a fair copy, you draw from behind. So let's be here. We use our sketch, we count the number of nodes. We have node 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we draw 12 of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then this was from one source. We have that. Then the 3. If you cultivate, it had 3 outcomes. 1, 2, 3. So the 3 outcomes shares the same source. So 1, 2, 3. Then we have that. We have that. We have that. And we have that. So you sell to the company. When you cultivate, it can either be high, medium, low. You sell to the company, high, medium, low. To the company, high, medium, low. Then you go back to the sketch. 1, 2 from the same source, 1, 2 from the same source, 1, 2 from the same source. So 1, 2 was from the same source, which was a decision. 1, 2 from the same source, which was, it's either you sell or you cultivate. Sell, cultivate. Sell or cultivate. Then the 2 options, I mean the 2, yes, those are the 2 are coming from the same source. The 2 are coming from an outcome where the information from the expert can either be accurate or not accurate. And then you come to the grad option, expert or no expert. Expert, no expert. So then once you're through with drawing your fair copy, you label the nodes. Apart from the add nodes, all the other nodes, you label them going backward. This will be node number 1, number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You label all the nodes apart from the add nodes. And then we bring our payoffs here. So let's read the question again. You want us to read the question again so that we can insert all the information given. So we're told that Collins Simiyu recently acquired a piece of land in Kamuru. A property development company has offered him 300,000 for the piece of land. So that means, let's go to the payoff. If you sell, so this was, sorry, yeah, if you sell, you are selling to the company, you get 300,000. If you sell to the company, you get 300,000. If you sell to the company, you get 300. Then we have the set of the demand. We have high, medium, low, high, medium, low, high, medium, low. Let's continue. We're told that he has to make a decision on whether to cultivate the land or sell it to get property development. If he decides to cultivate the land, there is probability of getting high, medium, or low harvest. The expected net income for each of the above states of harvest are shown below. If the state of harvest is high, you will get a net income of 500. 500 whenever it's high. If it's medium, you get 100,000. For the medium, it's 100,000. And then when it's low, you get a loss of 20. Then you're told that from the past experience, so now let's be here. You're told that from the past experience, you're given is that from the past experience, that means in this case, you're not considering the expert. When there is no expert, and then that's when you're using your past experience. You're told that from the past experience, there is a 10% probability that the harvest will be low. If there is no expert, that means you're using the past experience, and the probability of getting low harvest is 0.1. 30% probability that the harvest will be medium, 30%, and 60% that the harvest will be high. You have that. Then after that, Collins Simiyu can engage an agricultural expert to carry out the survey on the productivity of the land which will cost him 30,000. If you go for the expert, the value of the information will be 30, show 30, but in bracket, show it's an outflow. The expert gives the following information as to the reliability of such survey, which can either be accurate or not accurate with equal probabilities. So if it's accurate, probability is 0.5. When it's not accurate, it's 0.5. Then you are given the result of survey. If the outcome was accurate, so let's be here. If the outcome was accurate and the state of harvest is high, what's the probability? 0.7. If it's accurate and the state of the harvest is high, probability will be 0.7, medium will be 0.2, and 0.1. If the result of survey is not accurate, probability of having high harvest will be 0.5, 0.2, and 0.3. And then the probability of C selling to the company is 1 because the outcome is 1. If the outcome is 1, probability is 1. Good. So now we have that information. Now with that information, actually what you can see, how do you differentiate when to use a dot to differentiate an option and outcome? For all the option here, option, they have no probabilities and they have the dotted line. But the outcome do have probability. Can you scan, or wherever we have used a complete line, there is probability. That means that's a what? That's an outcome. So with that, let's get the EMV. So how do we get the EMV? How do we get the EMV? EMV. Node 1, node 2, node 3, like that. Node 4, 5, 6, 7, 8, 9, 10. So let's start with node 1. Node 1 has only one outcome. And this outcome, you can get 300, and the probability of occurrence is 1. So you'll be taking 300 times probability of 1, and you get 300. So let me write it there, 300. Let's go to node 2. Node 2 had 3 outcomes. So that means you can get 500 with probability of 0.7. You can get 100 with probability of 0.2, or you can get negative 20 with probability of 0.1. So what do you get? And you have 368. So node 2, we have 368. Node 3 has only one outcome. You can get 300,000 with probability of 1. So 300 times 1, you get 300. So node 3, we have EMV of 3. Node 4, we have 3 outcomes. So you can get 500 with probability of 0.5, or you can get 100 with probability of 0.2, and also you can get negative 20 with probability of 0.3. To get 264. Node 5 will be 300. It's 300 times 1, you still get 300. Node 6 has 3 outcomes. So we'll be having 500 with probability of 0.6. You can also get 100, probability of 0.3. You can also get negative 20 times 0.1. You get 328. 328. So from node number 6, let's go to node number 7. Now in node number 7, these are options. And for the option, you take the one with the highest EMV. So for example, node 7, we had 2 outcomes. You can either sell or cultivate. So the option is yours. So if you sell, you are getting an EMV of 300. If you cultivate, you are getting of the 368. You select the one with the highest EMV. So in this case is 368. Node 8, sell or cultivate. You should sell because you have 300. That's the maximum. Node 9, selling and cultivating. Cultivating has the highest EMV with 328. Then from node number 9, we go to node 10. Now, node 10 has probabilities. So we need to get the EMV. So how do we get that? So let's be here node 10. Node 10 has two outcomes. You can get 368 with probability of happening of 0.5, or you can also get 300, that's from node 8, with probability of 0.5. Then you deduct. For you to get that, you must incur a cost of hiring the expert of 30,000. You minus 30. So what do you get? And you get 304. So let me repeat again. So I'm working for node number 10. Node number 10 had two outcomes, accurate or not accurate. When it's accurate, the EMV is 368 with probability of 0.5. When it's not accurate, it's 300 with probability of 0.5. You get the EMV. Once you get the EMV, you deduct the cost you incurred to hire that expert to give you that information, and you get an EMV of 304. So node 10, we have 304. Then from node 10, we go to node 11. So node 11, it has two options. You either go for expert or no expert. Now we say that for the option you just select, you don't compute anything. So, and you take the one with the highest EMV. If you go for the expert, the EMV is 304. No expert, the EMV is 328. So take the highest, which is 320, 328. So that means if you have to make your decision, you have selected 328 so that you advise no expert. If there is no expert, remember you had two decisions. Between selling and captivating, which is the best? You see node 9 had 328. 328 was from node number 6. That means you should captivate. So you can comment or advise no expert and cultivate the art. That's how you're getting your 20 marks. So let's go back to the question. What was required? Number 1 was construct a decision tree for the above problem. We have that. Number 2, the expected monetary value for each decision. You have computed the EMVs. And then number 3, decision that you would recommend. Good. So you can take a screenshot of that. So in our next session, of which I'm planning to be giving you 2 classes per week. So kindly go through forecasting and correlation, as well as game theory. And also you can look at time series. So we shall communicate when we'll be having our next class, but you're planning to give you 2 classes per week. So and that's the end of the session.